Okay, so today we will continue our class, okay, which is more LLU and instruction that involving the GPRs. Okay, so in the next few slides, we will see the instruction, okay, that involve the GPRs. Okay, one of those instruction is, in the previous class, we already learned about the ADD, and then you have the MOV and etc. Now we're going to see another different instruction, ALU instruction actually, okay, that use the GPR to temporarily store your data. Okay, so this one here, let's look at the INC. So INC instruction increment the content of RD register by 1. So INC ni actually is your increment lah, to increment the content of your register, your GPR by 1. So this is the syntax here. Ini dia punya syntax INCRD, in which this syntax here, okay, this instruction here increment the content of RD by 1, and your RD can be from R0 to R31. Okay. For example here, so you're going to add 1 to the content of R2. Okay, so you just use the INC R2. So what happened is R2 equal to R2 plus 1. Okay, so you increment the content of R2 by 1. So let's look at another examples here. You are going to increase the content of data memory location at 080x430. Okay, dekat address 430, you want to increment the content, okay, by 1. So how to do that? Okay, first thing first, because this one here involving the GPR. So since your content is inside your, what we call here, inside your memory location, inside of your RAM, so what you're going to do is you need to load the content of this address here to your GPR dahulu. Okay, you need to load the content of from this address 430 to your GPR. Okay, from there you increment that R20, okay, your GPR, and after that you store back the incremented value to that location. Okay, so this is the instruction. Okay, next we go to the next instruction. Okay, DEC. DEC stand for the decrements. So the DEC instruction decrement the content of RD by 1. Okay, so tadi you increase by 1, now you want to decrease by 1, so you using the DEC instruction. Right, so this is the, what we call here, the syntax DECRD, in which after you execute this instruction, what happen is RD equal to RD minus 1. So the content of the RD is decreased by 1 every time you execute the DEC instruction. Okay, so this RD here can be from R0 to R31, because this one not involve the what we call here the immediate data. So we can use, okay, kita boleh guna R0 to R31. Okay, for example, okay, you are going to subtract 1 to the content of R10. Okay, so kamu nak tolak R10 by 1. So what you're going to do is we just use the DEC R10. Okay, no need to use the SUB, the subtract instruction. Okay, because you're going to subtract by 1 only, so we can use the DEC instruction. So what happens after you execute this instruction is R10, okay, any value from R10 equal to that value minus with 1, and then you store back the result to your R10. Okay, so another example. Okay, you're going to put the value 3 into R30. Okay, nak letak 3 to your R30. Then the value of R30 is decremented 3 times. Okay, so now you have an immediate value 3, and then you're going to put to R30. So what you're going to do is, because this is an immediate value, so you need to use the LDI instruction. Okay, so because this is nombor luar, okay, the immediate value, so you're going to use the LDI instruction, so that this value here you put to your R30. Okay, after this value you save to your R30 or store to your R30, Then after that, you can decrement the R30 3 times, okay, by using the instruction 3 times kat sini. Okay, DEC R30. So the first instruction here, what happen is your R30, after you execute this instruction, the R30 now become 2, and then you decrement again, the R30 now become 1, and once you decrement the R30 again, the R30 now become 0. Okay, the content of the R30 become 0. Any question up until here? Ada soalan tak? Ke I move too fast? Semua boleh dengar Okay, next we going to see the sub instruction. Alright, so the sub instruction tells the CPU to subtract the value of RR, okay, which is from your source register, from RD, so means that RD minus RR, and put the result back into your RD register. So this is the syntax, sub RD/RR. You see here, the syntax here, okay, it involves the between two register. One is from destination, the RD, and the other one is from source register, RR. So what happen is after you execute this instruction, RD is equal to RD minus RR. So you tolak dulu RD, tolak dengan RR, and put the result to your RD. Okay, for example here, you're going to subtract 25 from 34 values. Okay, you're going to do the 34 minus 25, and then put that value to your register by using the sub instruction. So what are you going to do? Okay, since this one here, okay, this value here is an immediate value. So what you're going to do is you need to load this value to your GPR dahulu. Okay, why? Because the sub instruction involve between two GPR. So that's why you need to load these two number here to your GPR. Okay, you can use any GPR from R16 to R31. Why? Because these two number are immediate data. Okay, so we're going to use the LDI instruction. So LDI R2034 and LDI R21 OX25. So what happens is after you execute this instruction, okay, R20 now have 34, and this one R21 got OX25 value. Okay, then after that you can use the sub instruction. Okay, sub R20 with R21. Okay, and then what happens is after you execute R20 34 minus with R21, which is 25, and put the result to R20. Okay, if you put something like this, R21, R20, then your instruction will be wrong. Okay, your program will be wrong. Sebab kamu nak tolak 34, okay, 34 minus with 25. If you write something like this, what happens is now 25 minus with 34, which is wrong lah. Okay, so let's look at another example here. You are going to subtract 5 from the content of location 300 and store the result in the location, okay, 320. Okay, so buang yang ni satu. Okay, you just discard this, the extra zero kat belakang tu. Okay, so what you going to do? Okay, you're going to subtract 5 from the content of 300. Okay, so your punya content is location is at 300, address 300, and then you're going to subtract with 5. Okay, which is this is the immediate value, and then this is the location in RAM. So what you're going to do is first you can, okay, we need to get the content from this location, this RAM, this address to your GPR, and then at the same time you're going to load this value here to another GPR. Okay, so we use the LDS-R0, okay, OX300. So what happen is R0 will have the content from address 300. So any value at address 300 will be stored to your R0. And then load I R16 OX5. Okay, so what happens is you put number 5 here, okay, the value 5 to your R16, and then sub R0 with R16. So what happens is R0 minus R16 equal to R0. So any value that you load from 300 minus with 5 and you put back to your R0, and then the question asks you to store the result in location 320. Okay, you're going to store the result to 320. So what you're going to do is you need to use the STS instruction. So STS OX 320 R0. Because why R0? Because this is the result after you do the subtraction earlier. Alright. So so the result now you store to address 320 inside of your RAM. Okay, so this is for the subtract instruction. Okay, SUB instruction. We have many instruction. Okay, in the next what we call here in the next chapter. Okay, this is just for the introduction part je lah. Okay, so later we will see more detail on the other instruction. Okay, so there are many instruction that involve there are many others ALU instruction available in the ATmega32 in the AVR actually. Okay, such as ADD, ADC, and means that you're going to do the logical and EO, you're going to use the logical exclusive OR, and then you have OR instruction. This is for the logical OR. SBC means that you're going to subtract the value with a carry. SUB subtract the value without a carry. Okay, this instruction you will learn in the next chapter. Okay, more detail in the next chapter. And then we have another ALU instruction, okay, such as a CLR, means that you're going to clear your register, okay, and then INC to increment, DEC to decrement, COM you're going to use to do the one complement, NEG, okay, this one is negate, okay, in which you're going to do a second complement, ROL, ROR means that you're going to rotate your value to the left or to the right, LSL, LSI, ASI, and swap. Okay, this one also you will learn in the next chapter. Okay, yang ni dalam chapter 6 if not mistaken, this one ya. Right? Okay, so any question for the ALU instruction? You have many ALU instruction actually. Okay, ada soalan tak up until here? Okay, so if not question, next we go to the AVR status register. Okay, so like other microprocessor, the AVR has a flex register to indicate arithmetic condition such as the carry bits. So every time you do the arithmetic condition, then the flex register will change according to that instruction. Okay, the flag register in the AVR is called a status register. Okay, so this status register is important register in the AVR. Okay, so the status register is a 8-bit register that contains of C, Z, and V, is S, and H. They are called conditional flags. Okay, so this flag here indicates some condition that result after instruction is executed. Okay, so this you have 8 flags kat sini inside of your status register. Okay, so each of these flags will change according to your instruction. Okay, the content after you execute your instruction. Okay, so let's look at the first flag. Okay, we call it as a C, which is this is the carry flag. Okay, this flag is set. Okay, dia akan jadi 1. Set is 1 whenever the carry there is a carry out from bit 7 in which after 8-bit addition or subtraction. Okay, for example lah. Okay, you're going to add two numbers. Okay, so this let's this is your number 1000, 8 bits number. Okay, and then you add this number here. What happen is, so you add these two number, and then 1 plus 1 you get 1, and you have a carry kat situ. Okay, so this one, whenever you have a carry at your bit, what we call here bit 9. Okay, this is a, you have a 8-bit data. Okay, bit 9. So what happen is the carry will equal to 1. Every time you have the carry, so the C flag will equal to 1. Okay, next we have the Z. Okay, the Z flag. The Z flag is the 0 flag. Okay, this flag reflect the result of an arithmetic or logic operation. Okay, if the result is 0, then Z equal to 1. If the result is not 0, then Z equal to 0. Okay, for example, okay, you do this addition. Okay, so kita ambil contoh yang ni. You do this addition, and then you see this result here. Okay, you get value. You have a value inside here. So what happen is automatic Z equal to 0. Because why? Because the content after you do the arithmetic operation has a value inside here. So the Z equal to 0. Let's say lah kalau you tambah, okay, you do the addition process. Okay, for example, something like this. Okay, you add these two number here, and then you do the addition. Okay, suddenly you get 0, 0, 0, 0, 0. Means that now the Z is set. Z jadi equal to 1. Okay, because why? Because the result after you do the addition process is 0. Then the Z is set, which is equal to 1. Okay, next the AND flags. Okay, this is the negative flags. Binary representation of signed numbers use D7 as the sign bit. Okay, so every time you going to use the what we call here sign number. Okay, bit 7 here. Okay, the bit 7 kat sini will represent your either you are either it is a signed number or unsigned number. Okay, the flag reflects the result of an arithmetic operation. Every time you do the arithmetic operation, and then the CPU will look at this bit number 7 here. Okay, if the D7 bit is 0, then N equal to 0. Okay, so every time you do the what we call here the addition, the subtraction, and then the CPU look at this bit 7, and then you get the 0 there. Okay, the result is 0. So what happen is N equal to 0. So the CPU know that then this number here is a positive number. Okay, but if the bit 7 is 1, then N equal to 1. Means that the result is in negative numbers. Okay, then we have the V flag. This is for the overflow flags. Okay, the flag is set whenever the result of a signed number operation is too large. Okay, causing the high order bit to overflow in the signed bit. Okay, means contoh lah. Okay, you do the addition. For what we call here for the signed number. Okay, let's this two number here is a signed number. Okay, so you do the addition. Okay, so you buat penambahan kat situ, and then you get 0, 0, 0, 0, 0, 0, and this is 1, and you get 1 kat situ. Okay, so what happen is, since this value here, okay, since this is your sign, But because you have, after you do the addition, you see here, you have a carry from bit 6 to bit 7, then the V flat equal to 1. Okay, because you after you do the operation, you have the overflow from this magnitude. This is your magnitude, and this is your sign bit actually. And then from your magnitude to your sign bit, then the V flat equal to 1. Okay, and then as for the sign flat, okay, the flat is the result of exclusive OR of N and V flat. Okay, so you do the exclusive OR from your N and V flat, and then you get the S value. And last but not least is your H. The H, this is for half carry flex. Okay, if there is a carry from bit 3 to bit 4 during add or sub operation, this bit is set. Otherwise, it is cleared. Contoh lah, I give you another contoh. Okay, so this is bit 0, 1, 2, 3, 4, 5, 6, and 7. Okay, you do the addition. Okay, 0, 0, 0. And then you have 1 kat situ. And 0, 0, 1. Okay, after you get this result here, what happened is, since now you see here, this is your bit 3 and this is your bit 4. Okay, after you do the addition, you have a carry from bit 3 to bit 4. So what happened is, H equal to 1. Okay, so let's look at another example. So you have this one, contoh. Okay, 0011. Okay, you tambah this one here, this number here. So there is no carry from bit 3 to bit 4. What happens is your hash automatic become 0. Okay, so any question for this? Okay, let's look at this example here. Maybe kita akan jumpa the negative punya example. Okay, so Josh asking that what are the difference between overflow flag and carry flag? Okay, for the overflow flag, okay, the carry is from bit 6 to bit 7. While for the carry flag, there is a carry from bit 7 to your bit 8. Okay, so this is your bit. Okay, you have a 8-bit data. D0 denoted by label by D0, D1, D2, D3, and then D4, D5, D6, and D7. Okay, if you for the carry flags, okay, every time you do the addition and then suddenly you have a carry from bit 7 and then you have a carry to your bit 8, so that one called as a carry flag. Okay, while for the overflow, okay, overflow only occurs when you do operation involve the sign number. Okay, why? Because the bit 7 now become your sign bit. Okay, bit nombor 7 ni jadi kamu punya sign bit. Okay, if you do the addition or subtraction, there is a carry from bit 6 to bit 7, then what happens is the V equal to 1. Okay, that is the difference between overflow and carry flags. Okay, so let's look at this example here. Okay, Coach Zuan asking that when we get V equal to 1, is it a must that N equal to 0? Okay, it depends on the result of your N. If the N is what we call here, if the bit 7 is 0, then the N is 0. If the bit 7 is 1, then the N is 1. Okay, let's look at this example. Okay, show the status of the Z flag during the execution of the following program. Okay, so let's look line by lines. Okay, instruction by instruction. LDIR24. Okay, you're going to see the Z flags ya kat sini. So what happen is kat sini R20 now get 4. Okay, and then decrement. Okay, so this is the solution. LDI R24. So value of R20 now is 4 and the Z flag is 0. Why 0? Because you have a value inside of your R20. Okay, then decrement R20. So what happened is R20 is decremented by 1. So now your R20 equal to 3. What happened to your Z flag? Z flag still 0. Why? Because you have a value inside of your R20. And then you decrement again your R20. Now your R20 becomes 2. Z flag still 0. Why? Because you still have a value inside of your R20. Decrement R20. So R20 now decremented by 1. So it becomes 1. And the Z flag still 0. Why? Because you still have value inside of your R20. And then after you execute this, the last instruction here, decrement R20. So now what happens is your R20 equal to 0. So automatically the Z flag is set become 1. Why? Because there are no value inside of your R20. Okay, next we have another example. Okay, you are going to show the status of C, H, and Z flags after the addition of 3, 8, and 2F in the following instruction. Okay, so let's look line by line. Okay, kita buat line by line of this instruction here. So LDI R60 O at 38. So what happen is R16 akan ada nombor 38. And then load I R17 to F. So R17 will get 2F. Okay, and then ADD R16 and R70. So you're going to add 38 plus with 2F. So in this, to do this, okay, I advise you to convert this hexadecimal number to a binary number, because you're going to see what happened to your bit 7 and bit 3. Okay, because you want to identify the C and H flags. Okay, so tukarkan dulu kepada binary. Okay, so 3 by using the 8421 method. So you already know this one here. Macam mana nak tukar, how to convert from hexadecimal to binary. So 38 which is 0011, 81000, 2F is 0010, and F is 1111. Okay, and then so you tambah aja. Okay, you add these two number here. Okay, so it become 0 plus 1 you get 1, 0 plus 1 1, 0 plus 1 1, 1 plus 1 you get 0, and then you have a carry here. And then 1 plus 1 you get 0, you have a carry. 1 plus 1 plus 1 you get 1 1. Okay, you have a carry kat situ and here. Okay, so now we're going to identify the flags. Okay, C. What happened to your C? Is there any, what we call here, any carry from bit 7? Okay, this is your bit 7 ya. Yang ni bit 7. D7. Okay, so this is your D4 and this is your D3. Is there any carry from D7 to bit 8? Okay, from D7 to D8? Okay, no carry kat sini. There are no carry kat situ. So what happens is C equal to 0. Okay, next we look at the H. Is there any carry from bit 3 to bit 4? Yes, you see here you have a carry kat situ. Okay, after you did this, di penambahan here, this addition here, you have a carry there. So what happens is H automatic become 1. And last but not least is your Z flags. Alright, so Z flags. What happened to your Z flag? Since the result here, you got a value inside of this R16. So Z flag automatic become 0. What about your N flags? Okay, siapa nak tolong N flag? What is your N flag value? Okay, so we looking at this bit nombor 7. Okay, we looking at bit nombor 7. Since your bit 7 is 0, then your N is 0. Okay. Okay, let's look at another examples. We have more examples. Okay, we have few examples here. Okay, show the status of the C, H, and Z flags after the addition of 9C and 64 in the following instruction. Okay, so you do lines by lines. Okay, so this line here, what happens is R20 now have 9C and R21 after you execute this instruction have 64. Okay, and then you're going to add R20 with R21. So as I mentioned earlier, so better you change this number here, hexadecimal to binary. Okay, so by using the add4to1 method. So 9C, okay, so what is 9? 1001. What is C? C is ABC 12. 1100. Okay, and then 64, so this is 0110. 4 is 0100. Okay, and then you add this number here, so become 000. Okay, and then 0. Okay, so now let's look at the C flags. Okay, so this is your bit 7. Yang ni dia bit 7. And this is your bit 4. And this is your bit 3. Okay, is there any carry flag from bit 7 to your bit 8? Yeah, ada carry flag kat situ. So what happen is C automatically become 1. Okay, and then H. What happened to your H? H, there is a carry flag from bit 3 to bit 4. You see here, you have a carry. Sorry, you have a carry from bit 3 to bit 4. So what happens is H automatic become 1. What about Z? Okay, since the Z here, no value inside of your Z because the value here is 0. So automatically Z equal to 1. Okay, what about N? Siapa nak tolong N? Okay, we look at bit 7 lah. Okay, so bit 7 still 0, so N is 0. Okay, next examples. Okay, show the status of the C, H, and Z flag after the addition of 88 and 93 in the following instructions. Okay, so you do all this thing here. So this is R20 sama dengan 88. And this one here, R21 equal to 93. Change to what we call here to binary number. So you get 1000, 1000, and then 93 is 1001 and 0011. Okay, so you add this number here. So dia akan jadi 11011001, and then you have a carry flag here. So see what happened to your C. C equal to 1. Why? Because you have a carry from bit 7 to bit 8. And then what about your H? H no carry flags kat situ. So H automatically become 0. And then what about your what we call here? Z. Z is 0. Why? Because you have a value here. And what about N? Okay, siapa nak tolong N? Look at the is it N0 or N1? N1. Okay, why? Because N kita looking at this number here. Okay, bit 7. Okay, you see back for the N. Okay, if you're using the we're looking at the bit 7. Yes, it is not negative. Okay, so the negative here, okay, for the negative number, okay, later it will shown by this S flag kat situ. Okay, so this is a few example lagi, tapi similar to what we did earlier. So now we finish the module 2. Okay, so I give you 5 minutes break, and after that we continue with module, what we call here, with module number 3. Okay, now we continue with module 3. So module 3 is Atmega 32 addressing modes. So inside of this module 3, you will learn to what we call here, how to get a data, how to move a data by using a different addressing mode. Okay, we have 3 or 4 addressing modes you need to learn. Okay, so let's look at the, okay, before we go more details on the addressing modes. Okay, we need to know the register that available inside of your Atmega 32. Okay, so this is the Atmega 32 registers, okay, that you need to know. Okay, the first one here called as a general purpose register. So you already learned about this one here. Okay, so it level from it the level of general purpose register is R0 to R31. Okay, total number is 32 lah, and the size is 8-bit data. Okay, what is the function of this GPR is to store the data temporarily. Okay, and then we have a address pointer. Yang ni pun kita dah belajar in the previous class. Okay, which is you have 3 pointer register, X, Y, and Z. Okay, so total number of 3 lah. Okay, what the size of this pointer register is 16-bit wide. Okay, why? Because the kalau when you recall back the X, okay, the pointer register X is actually a combination from R26 and R27. This is for X. R28, R29 is your Y, and R30 and to R and R31 is your Z pointer register. So the size is 16-bit. Okay, so what is the function? Is to store the address pointer. Okay, next we have the stack pointer. Okay, so the label of stack pointer is SP. Every time you see the SP means that belongs to the stack pointer. So, okay, you have one stack pointer in Atmega 32. The size of the stack pointer also 16-bit. Okay, so this stack pointer used to store pointer to a group of data known as the stack. Okay, in the chapter 7 or 8, you will learn about this stack pointer. And then we have a program counter, which is labeled by the PC. Okay, the size is 14-bit. Okay, so this program counter is used to contains the address of the next instruction to fetch and execute. So this one here, dia akan simpan the address of your next instruction. Okay, when you do the fetch and execute process. And last but not least, okay, the one that we learned just now, which is your status register. Okay, so SREG, every time you see the SREG, that is a status register. So it is a 8-bit wide. Okay, so this status register function is to contain information of the result of the last instruction. So every time you did the last instruction, the flags inside of your status register will change accordingly. Okay, so now we go to the addressing modes. Okay, so the CPU can access the data in a various way. Okay, so the data might be from your GPR, or that data inside of your memory, inside of your RAM, or that data is provided as an immediate value. Okay, there are three type of data kat sini, sama ada dalam register, your GPR, or in your RAM memory, or inside, or provided as a immediate value. Okay, these various way of accessing data are called addressing mode. Okay, the way that you're going to access this data here, either it is inside of your register, memory, ataupun immediate value, we call it as a addressing mode. Okay, the various addressing mode of microprocessor are determined when it is designed. Those cannot be changed by the programmer. Okay, so the addressing mode is fixed. Okay, you cannot change the way you're going to access that data, the way you're going to get that data. Okay, so there are three basic addressing mode for AVR. First, we call it as a register addressing mode. For register addressing mode, we can divide it into the small, such as a one register addressing mode, two register addressing mode, and immediate addressing mode. Okay, and then we have a direct addressing mode, and the last but not least is indirect addressing mode. Okay, so before we go more detail on the addressing mode, let's look at this, what we call here, the instruction format, okay, for assembly language. Okay, so the format of the source files, your assembly language is something like this. You have a label, okay, and then followed by the colon here, and then you have a mnemonics in which your instructions, followed by your operands. Operand is what you're going to do, and then you have a command. Okay, for example here, okay, here this is your label. Okay, why label? Because you have a column kat situ, and then add is your mnemonics, R1, R2 is your operands, and this semicolon here, every time you see the semicolon and then followed by the description, this means your command. Okay, means that you what this the thing that you're going to write, okay, for each line of the instructions. Okay, so this is a contoh lah, a few contoh of assembly language. Okay, so this is the instruction. Okay, for the first line here, no label kat sini, tak ada label. Okay, this is your mnemonics, LDI. Operand is R16 with OX5, and this is your command. Okay, so this command here, okay, you see here, R16 equal to 5 after you execute this instruction. Okay, and then this one here got label, okay, which is L1. So for the one with the label, we will usually use when you're going to do a looping. Okay, every time you want to do a looping, okay, you want to do a loops, okay, then we need to put a label. Okay, so let's look at the first addressing mode, which is a register addressing mode. Okay, so in this addressing mode, the operand is a register that is only engaged with one register. Since this is a single register addressing mode, so the operand only have single register, which is ada satu register only lah. Okay, involve the one register only. Okay, the instruction can operate of any of 32 registers. Okay, you can use any register from any GPR from R0 to R31. Okay, for example here of single register addressing mode such as NEG, you see here NEG R18. Okay, means that you only use the one register kat situ. You have a COM. Okay, you're going to do a complement R19, increment R20, decrement R21, ROR R22, which is this one here belong to rotate right R22. Okay, so this is an example of single register addressing mode. Why? Because it only involves single register. Okay. Next, two register addressing modes. Okay, so two register addressing mode involve the use of two registers to hold the data to be manipulated. Okay, the instruction can operate on any of the 32 registers GPR. Okay, so you can use any register from R0 to R31. One of the register is the source register, and while the other register is a destination register, because you have a two register, so one is coming from your source register and the second one is your destination register. Okay, the one that you're going to put the result to. Okay, so this is an example of two register addressing mode, ADD R20 R23. You see here, it involves of two register, SUB R29 R20. So this is another two register addressing mode, AND R16 R17. So this is another two register addressing mode. So every time you see the instruction that involve of two registers, so that one belong to two register addressing modes. Okay, last is immediate addressing mode. Okay, so the constant value is sometimes referred to as immediate data. Okay, since the operand come immediately after the opcode. Okay, means that this one only involve the immediate data ataupun outside data ataupun constant value. Okay, so immediate addressing mode can be used to load data to any of register from R16 to R31 only, because you're using the immediate data. Okay, you involve the immediate data, so the GPR that you're going to use is from R16 to R31 only. Okay, so the immediate addressing mode also used for arithmetic and logic instruction such as LDI. Okay, every time you see the instruction that ended with I, so you know that that one belong to immediate addressing mode. Setiap kali kamu nampak je instruction yang ada ended with I at the back, so this one here belong to immediate addressing mode. So example of immediate addressing mode such as LDI, sub-I, ANDI. So this is your registers, destination register, and this one here is your, what we call here, your constant value ataupun immediate data. Okay, so you can also use the .equ directive to access immediate data as shown below. Okay, for example lah, .equ count sama dengan OX30, means that every time you use the word count, you know the CPU know that count is 30. Okay, the value of count is 30. Contoh macam ni lah, LDI R16, count, means that you're going to load nombor 30 to your R16. So, okay, you can replace this value here with another names. Okay, so but you need to use the .equ directive. Okay, this is .equ means that equate. Okay. Okay, so any question for register addressing mode? Ada soalan tak untuk register addressing mode? So register addressing mode only involve of the registers. Either is one single register, two register, or immediate data. Ada soalan tak? Okay, no question. Okay, so we go to the next slide. Okay, so let's look at the direct addressing modes. Okay, so in direct address mode, the operand data is in a RAM, which is in your memory location, whose address is known. Okay, since this is a direct address mode, the location of your data is inside of your RAM, which is you know the address, that address. And this address is given as a part of the instruction. Okay, so the address field is 16-bit address, can take value from 0000 to FFFF. But, okay, there is a but, because we using the Atmega32, okay, so this is our data memory. Recall back, kita punya data memory. Okay, so data memory can be divided into three parts, okay, which is first GPR, IO, and RAM. Okay, the static address here is dekat 000000. Since our RAM size is 2 kilobyte, so the RAM end, okay, RAM end ataupun RAM end is equal to 085F. That's why the address field for Atmega32 is from 000 until 085F only. Okay, sampai you punya RAM end. Okay, so for example of direct addressing mode. Okay, LDS R19 OX560. Okay, what happened here? Okay, you're going to load value from space, which is your location, your memory location at 560, put to your R19. Okay, so I lukis kita punya data memory. So this is your data memory. Okay, so this is your R19. So this is your RAM. So this one here, this is address 560. So what happen is, after you execute this LDS R90 OX560, what happen is, you take the value from address 560 560 and put to R90. Okay, so this is what the LDS do. Okay, take the value from your memory address that you know that location by using the direct addressing mode and put to your R90. Okay, next, another example of direct addressing mode, STS OX40 R90. Means that you're going to take the value from R19, lepas tu store it dekat address 40, which is somewhere around here. Okay, so you put the value of R19 to address 40. So this is your addresses. Address of your memory location. Okay, so this is for the direct addressing modes. Then we have IO direct addressing mode. Okay, what are the difference between direct addressing mode and IO direct address mode? Okay, so the IO direct address mode can address only the standard IO register. Okay, so this one hanya kita access the standard IO register. So how many IO register do you have? Ada berapa IO register in Atmega32? Can you tell me how many IO register in Atmega32? Anyone? Okay, we have 64. Okay, recall back. Okay, always lukislah you punya data memory. Okay, you have 32 GPRs. Ada 32 kat sini. And then you have a IO followed by IOs, which is 64. And then you have a RAM, 2 kilobyte. Okay, so in and out instruction only can be used for the IO register. Kat sini saja. Okay, you can access the IO register only. So the address of this IO register can take value from 00 to 3F. Okay, so recall back, untuk IO register you have two type of addresses. Satu kita panggil data memory address and satu lagi is IO address. Okay, so IO address starting from 00 to 3F, while this one here starting from 20. Kalau kamu guna data memory address is starting from 20 until 5F. Okay, if you use the LDS and SDS, you need to use the data memory addresses, while if you use the in and out instruction, you're going to use the IO address. Okay, for example here, example of IO direct address mode. Okay, out OX15 R19 means that you're going to put R19 value from R19 to address 15, which is kalau kamu refer back to your IO table. Okay, so address 15, 15 betul ya, 15 ya. Okay, so address 15 in IO address, this is address 15 in IO address, actually your port C. Okay, so instead of memorize the what we call here the addresses of your IO register, better you use the name. Okay, so you can use the out port C R19. So these two here, these two instructions here actually equivalent. Okay, either you use the IO addresses ataupun you can use the name of your register. Okay, so another example in R26OX16, which is equivalent if you write in R20 pin B, because address 16 actually is your pin B punya location. Okay, so what happen is you read the value from your pin B and put to your R26. Okay, so this is the selected ATmega IO register addresses. Okay, this is the one that we frequently use. Okay, yang kita selalu gunakan. Okay, which is your pin B, port B. This is for the input output port, and for this one here, SPH, SPL, this belong to your stack pointer. Okay, so let's look at the examples. Okay, so you are going to write a code to send 55 to your port B. Okay, so there are three ways to write the code to send 55 to port B. One, by using the register name. Two, by using the IO addresses. And three, by using the data memory address. Okay, so kita lukis dulu. So this is your ATmega 32. Okay, this is your port B. Okay, so you're going to send this value here, 55, to your port B. So how to do that? Okay, first thing first, what are you going to do? Before you're sending this value 55 to port B, apa kamu nak kena buat? What are you going to do? You need to initialize your port B so that your port B become an input port or output port in this case. Yes, output port. Why output port? Because you're going to send the data from CPU to outside. So you need to initialize your port B as a output port. So how to initialize your port B as an output port? By sending what value to your DDRB? Is it send 0 or send 1? Because the DDR register will determine either you're going to make your port as an input or output. Okay, if you put 0, what happened to your port? Is it become 0? Is it become output or input? Kalau you send 0 to your DDRB. Okay, so 0 is input. If you send 1, if you put 1 to your DDRB, it become output. So what we're going to do? Okay, so sekarang ni because you're going to send the 55 to your port B, so you need to initialize lah your port B so that it become output port. So let's, okay, so we need to send 11111. Okay, why? Because we're going to make the whole port B as a output. Okay, so you send 111111 to your DDRB. So how to do that? First thing first, you need to load lah this number here to your GPR. Okay, so by using the LDIR20OXFF. Okay, so this value here you put to your R20, and then after that you can send that value to your DDRB by using the out DDRB R20. Okay, so what happens is after you execute this instruction, now automatically your port B equal to output port, become output port. Okay, next we are going to send this value here 55. Is it this value 55 inside your GPR? Not yet. Betul tak? Belum lagi. Okay, so what are we going to do? Okay, so we need to load this value to your GPR, and then after that you can send it to your port B. Okay, so that's why we use the LDI. Okay, you can use any of the register. Instead of R20, you can use the R21, R16, R18. Okay, so LDI R20 OX55. So what happened here is 55 you put to your R20, and then after that you send out to your port B register. So out port B R20. Okay, sebabnya why? Because now your port B become output port, so we're going to use the port B register. Okay, so you remember back, every of your port here you have 3 register, which is DDR, X, port X, and pin X. Okay, so if you make your port here as an output port, so you need to use the port X register. If you make your port here as an input port, then you need to read from your pin X register. Okay, any question? Okay, so this one by using the register name lah. Okay, so this is the register name. Port B and DDRB. Ada soalan tak? Any question, guys? Okay, so next, we're going to write the same things. Okay, now by using the IO address. Okay, you don't want to use the register name, you're going to use the IO address. So sama jugalah. What you're going to do is, first, you need to initialize your port B so that your port B become output port. And then after that, after you set your port B as output, then you can send out this value to your port B. Okay, so load IR20OXFF, and then out. Okay, so now we're going to find what is the DDRB punya address, IO address. Okay, look back at our what we call here table here. Okay, so DDRB. So DDRB, the address for IO address for DDRB is 17. Okay, so that's why we put out OX17R20. So automatically after you execute this instruction here, your port B now become the output port. Okay, then load IR20OX55. So you load this 55, okay, the value that you're going to send to your port B to your register, and then send out to your port B. Okay, we use the port B. So what is the IO address for your port B? Refer back to this, what we call here, to this table here. Okay, so untuk port B, okay, this is your port B. So the address for your port B, IO address of your port B is 18. So that's why you put out OX18R20. 20. So automatically 55 you send to your port B. So this is by using the IO address. Any question for the IO address? Okay, so every time you use the IO address ataupun register name, IO register name, okay, you can use the, okay, so these two here, you can use the in or out instruction. Okay, next, we're going to see the same process, but now by using the data memory addresses. Okay, so again, initialize your port B supaya port B become output port, and then after that, you can send out that value to your port B. Okay, so what you're going to do is load IR20OXFF. Okay, now we change from out instruction. Now we're going to use the STS instruction. Okay, every time you use the STS instruction, you need to refer to your data memory address. Okay, so what is your data memory address for DDRB? So refer back lah to this table. Okay, for the DDRB, so this is your DDRB. The data memory address is 37. Okay, so see here, the data memory address for DDRB is 37. So that's why here STSOX37R20. So automatically after you execute this line here, what happens is port B sama dengan output port. Okay, and then next we load this value here to R20, 55 to R20, and then we're going to send it to your port B register. So by using the STS, so now you're going to find out what is the port B punya address, data memory address. So refer back to this one here. Okay, port B addresses is 38, so that's why you put STSOX38R20. So automatically 55 now you send to your port B. Any question? Ada soalan tak? Is there any question for the direct addressing mode? Okay, for the direct addressing mode means that you know the address. Okay, the address where you're going to put or where you're going to read the data. Okay, so if no question, okay, next we go to indirect addressing mode. Okay, so this one here a bit more tricky lah compared to others two addressing mode. Okay, yang ni because it is indirect, so you need to focus lah on this part. So in the register indirect addressing mode, a register is used as a pointer, okay, to the data memory location. Means that you use another register to point out to the address of the location inside of your data memory. So in AVR register, okay, in AVR there are three registers are used as a pointer register, in which is made by combining two specific GPR. Okay, so we already know that we have three pointer register, which is pointer register X, Y, and Z. Since this X, Y, and Z is 16-bit wide, so you need to combine two GPR, which is for the register X is a combination of R26 and R27, Y, R28 and R29, and Z is a combination of R13 and R31. Okay, so the R26, R27, R28 until R21 can be referred to as a SL, XH, YL, YH, ZL and ZH respectively. Okay, apa maksud ni? L and H. Okay, so this is your pointer register X. Okay, since it is a 16-bit wide, dia adalah 16 bit, you can divide it into 2 byte. Okay, one is a low byte and the other one is a high byte. Okay, so this is a 8 bit. 1 byte equal to 8 bit, yeah, and another 1 byte is 8 bit. So the lower byte and high byte. Okay, so XL actually is your lower byte, X low, while XH is your high byte. So in this case, R26 become your XL, your lower byte for pointer register X, while R27 become your higher byte of your X register. Okay, for the Y, R28 is your low register YL and R29 is your YH. And last but not least, R30 for Z pointer register, R30 is a Z low and R31 is ZH. Okay, excuse me, I need to take a phone call. Okay, so where are we? All right, so you have 3 pointer register, which is pointer register X, Y, and Z. So 60 is a 60-bit, so you have a low byte and high byte of your pointer register. Okay, for example, let's do an example here. Following instruction reads the value of the location pointed to by the X pointer. So for the indirect addressing mode, okay, to read a data, to load a data from address location to your GPR, okay, we are going to use the LD instruction. Okay, so LD used to load the address that pointed to by pointer register X and put the value, the content inside of your R24. Okay, let's look at the example kat sini. Okay, so this example here, following programs loads the content of location OX130 into R18. Okay, so LDI XLOX30, LDI XHOX01, LDR18 8. Okay, so saya bagi contoh macam ni lah. Okay, so can you see my Microsoft Word? Semua dapat tengok tak Microsoft Word ni? Okay, great. So, sekarang ni kita ada LDI supply. Okay, LDI XL OX30 LDI XH 01 and then LD R18H. Okay, for example. Okay, so we draw sorry. Okay, so this is our data memory. Okay, so this is our GPR. Okay, GPR followed by IO, and then you have a RAM. Okay, so LDIXL30. What happened here? Okay, dekat R26. This is your R26. After you execute this instruction, you have a 30 kat situ. And then LDIXHOX01. So this is R27. Okay, after you execute this instruction, you have a 01 dekat situ. Alright, and then load R18X. Okay, so we're going to see this instruction here. What this instruction do? Okay, so what happen is you're going to load, okay, the value that are pointed by pointer register X and put it to your R18. Okay, first thing first, what are you going to do? Okay, first thing first, you're going to see your pointer register X. So this is your pointer register X. And see what is the address pointed by pointer register X. Okay, so this is your R26 and this is R27. Why? Because we know that R26 is your XL while R27 is your XH. Okay, so the content inside of your R26 is 30 while R27 is 0Y. So you know that your X now point to address 0130. Okay, so what happens is you go to this address 0130 which is around inside of your RAM, somewhere around here. 0130, and then what you're going to do is take the value and put it inside of your R18. Okay, letak dalam you punya R18. Okay, so this is the indirect addressing mode. This is how the indirect addressing mode works. Okay, so you need to know first what is the what we call here the address that pointed to by your pointer register. Go to the address, get the value and put to your register. Okay, contoh lah. I put another contoh lah. LDS R19 OX OX, let's say lah I put here is 87 for example. Okay, what happened here? If you execute this instruction, apa yang berlaku? Siapa nak tolong? Who want to help me? Okay, so I put another one. LDS, LDI, R19, OX87. Okay, so what is the difference between LDS and LDI? Okay, so watch closely. Okay, for this one here, LDS R90OX87 means that I need to go to address 87, which is somewhere around here. Contohlah kat sini, this is address 87. Okay, so this is address 87. Okay, get the value inside address 87 and store to my R19. Okay, so this is what happened when I use the LDS. Okay, for the second one, LDI R19OX87, you see the value is similar, but this one belongs to immediate data. Okay, so what happened is I get the value 87 from outside, store to my R19. So that is the difference. Okay, this one we use the register addressing mode. Okay, yang ni register addressing mode. Yang ni we use the direct addressing mode. We know the addresses. And this one here we use indirect addressing mode, which is the address. The addressing mode is located or is saved, pointed by your pointer register X. Okay, contohlah. Okay, you are going to use the indirect addressing mode. Okay, you're going to load the value from address kosong, from the same address 0x87, but you're going to use this indirect addressing mode. How to do that? Kalau direct addressing mode, you just use this instruction je lah. Okay, you just use this instruction. But now you're going to use indirect addressing mode. How to do that? Okay, so load value from address 087, put to your R19. Okay, first by using direct addressing mode. Okay, by using direct addressing mode, you just write down LDS R19 OX87. But the second method, instead of using direct addressing mode, you're going to use the indirect addressing mode. So macam mana nak buat? How to do that? Anyone? Siapa nak tolong? Okay, first thing first, what are you going to do? Okay, first thing first, you need to make sure that your pointer register pointed to address 0887 lah. Okay, how to do that? Okay, let's say like we use the pointer register Y. In this case, we use the pointer register Y. Okay, so Y. Macam mana we are going to make our pointer register Y point to this address 0087? How to do that? Okay, so you need to make sure that this one here, the YH and YL, okay, for the Y, because this is a 16-bit, you can divide it into 2 lah. Okay, so this belong to L and this belong to high. Okay, so this is your YH and this is your YL. So make sure that YL consists of 87 while YH consists of 00. So macam mana nak buat? How to make sure that the Y pointed to the address 0087? Okay, by using the first, you're going to load this number to your YH and YL. So LDI R20 berapa? R26, 7, 28. Okay, so this are R28 0887 and load I R29 0x00, and then after that you use the indirect address mode LD R19 Y. Okay, because why? Because kat sini after you execute these two instruction here, what happen here? Your Y now point to address 0087. Okay, any question? Okay, that is the difference between indirect address mode, direct address mode and registered address mode. Ada soalan tak? Yes, the position of for X, Y, and Z are fixed in Atmega 32. Okay, so one of your friends here saying that can we use the YL YH instead of R28 and R29? Yes, you can use. You can replace this one here instead of using the yang ni R28. Okay, you can replace with yang ni YL and this one here YH. Also can. Boleh. Okay, Dominic's asking how R19 can store 16-bit data. Okay, this R19 actually not store the 16-bit data. It takes the data from address 0087, which is kat sini, get the 8-bit data, which is we know that this is a 8-bit data, put to R19. Not 16-bit data. The 16-bit only for the addresses, not the content. Okay. Okay, so okay, so this is for the load lah. Okay, if you're going to load the data, okay, the what we call here the by using indirect address mode, we use the LD instruction. But if you're going to store the data by using the indirect address mode, we use the ST instruction. Dia sama je. Okay, so for example lah. Okay, following program store the content of R23 into location of 139F. Okay, for example, this is not Atmega 32 punya chip. Okay, because the addresses is 139F above our Atmega 32. Why? Because our Atmega 32 can support only up to 085F only. Okay, so first thing first, what you're going to do is, okay, you need to divide it lah. This address here, because this is a 16-bit address, so you need to divide it to low and high. So this one go to ZL and this one go to ZH. That's why, okay, you use the LDI ZL0X9F, okay, and then load IZHOX13. So automatically what happens is after you execute this instruction here, Z now pointed to address 013F. Okay, then after that you can use the pointer register what Z. Okay, so this one ganti ya. Make please do correction. STZR23. So any value from R23 you store to this address pointed by pointer register Z, which is the address 013F. Okay, so advantages of register address indirect address mode. So this one I think we stop here. Okay, tomorrow we'll continue with this slide. Boleh? Because you already learned a lot today. Boleh ya? Okay. Any question?